Oh, right. So, in the last hour, we already do this, right? We build the x and y variables and put it in this A data frame, right? And within this A data frame, we actually have the for this 2A5A4 customer, each of them I have their buying behavior for the first 3 months, okay? And I also know whether he buy or how much he buy in the last month, right? Okay, so we now have the X and has the Y for us to build the two model, right? Buying probability model for this target variable, and then the buying amount variable for this Y variable, right? So in this data frame, we have a bunch of X, and then we have these two targeting variable for us to build our buying probability and expected revenue model. Get it? Okay? Any question up to this point in time? Okay, so let's carry on. Now, after we have this data frame, right? This is our data set, I would say. So, as before, as I told you before a lot of times, nowadays we will not use all of our data to train the model, right? We will reserve some data to kind of like, we call it splitting into a train data and test data. And this test data is reserved for measuring the model accuracy, right? Okay, so we need to do the splitting. We need to do a split on this A data frame, okay? And it would split it into training and testing, okay? And we can do that. We need to do that in two different models, okay? The first model is like the probability model, right? Buying probability model, okay? The second thing is the buying amount model, okay? So let's do the now this code chunk is just to synchronize the data. I spell it wrong. It should be amount. Okay. So I only want to like kind of like synchronize the data within A and X and Z. Okay. I want to make sure that X and Z only contain the data inside A, right? And that would make things easier, right? Later on. Okay. So now we want to do the data splitting. Again, we can call this sample split function call, right? To split the data. We used it before, right? And you need to give it two things. The first thing is the target variable, right? And for buying probability, it is actually this binary variable, true or false, right? And then you also need to tell it what is the ratio that you want to preserve, you want to use for training. This is actually the ratio. We put 70% of data for training and then 30% for testing, right? And the reason that we give this target variable is that we want to keep the ratio of buying probability the same in the training and testing data. Okay? Because when we split the data for training and testing, besides the ratio of training and testing data, we want to keep the ratio of targeting variable, right, the same in training and testing, right? So so that the when we do the testing, it would like actually when you have data this big, right, you will see that when we do the splitting, it actually will return a splitting vector, right? And this splitting vector, the length of splitting vector is 2A5A4, exactly the same as the number of observation in A, right? Okay. So and this splitting record is like just this is the training and this is the testing, right? Okay. So A is this is total data set, right? And after the splitting, we have this many data in the training and this many record in the test. Okay. And now we I actually you don't need to do that, but I just want to show you that when you have a big data set and you do the splitting, you basically will see that not only the ratio of buy, but also the distribution of the buying amount will be very, very similar between training and testing. Okay? See, actually in this 3 lines of code, I actually do a density plot for buying amount, right? And I do it. This is for splitting true is for training, right? Splitting false is for testing, right? As you can see that for the training and testing data, their distribution of buying amount are quite similar, right? Okay. And this is actually a very very important theory in statistics, right? The reason that we can use statistics to do inference is because that when you do a random splitting, right, you will have the effect of like split the data into not only into 30% testing, that's 70% testing. It will also have the effect that even though you just do the random splitting, it will also have a quite similar distribution of the buying amount. Right? This is kind of like the power of randomization, right? Okay, and the power of randomization is the basic, is the reason that we can do statistics, right? So that is the very important concept that we can learn, right? You don't really actually need to do plot this chart, but I just want to show you that after we do the splitting, okay, it's actually in the training and testing, they are very, their distribution, okay, is kind of like very singular, right, for this target variable, right? Now, now we have to do the splitting for A into, we can use the splitting vector SPL to split A into training and testing, right? And that is for building the, we need to build 2 models, right? The first model is purchase probability, right? Okay, and the corresponding target variable is A buy, right? Okay. The second model we want to build is for predicting revenue, right? Okay. So to do that, we first of all, need to subset A using by, right? The reason that we want to do it is like out of these 2A5, A4 customer, only one six, only part of them, only like this many out of the 2, 3, 5, A4 customer, only 1, 3, 2, 4, 2 customer buy, right? And when we do the model for buying amount, right? We can only use the data that the amount is not NA, right? Okay. If amount is NA, then we do not have the Y variable to build the model, right? Okay. So out of this 2A5, A4 variable, we basically need to pull out the customer who actually buy in the February, right? And besides this filtering, we also do a mutate on all of this numeric variable, like the average buying amount, and this is the total revenue, right? And this is actually the buying amount in the February, okay? So, and these three variable, because their distribution is kind of like skewed, right? It would not actually comply to the assumption of linear regression, right? In linear regression, we want to make sure that our target variable and our predicting variable are in normal distribution, right? But these three column in these three variable, they are not normal, right? So in order to make them normal, we need to do a log transformation, okay? Usually in business data, when we're talking about money, right? This is usually the case. When you want to build a linear regression model for business data, usually you need to take a log transformation to make the distribution normal. Okay, otherwise you could like skew. Okay, so after doing the filtering and also the transformation, basically we have how many? We have n is 1, 3, 2, 4, 2, right? So I put the data in A2. Okay, so this A2 data only has 1, 3, 2, 4, 2 observation. Okay, so in order to do the revenue amount, buying amount model, right? We can only use the data. We can only use the data for those who actually buy in February, right? And this is the number of customers out of this 2A5, 5A4. Only this many data buy in February. So when we are building the buying amount model, we can only use the data from this 1, 3, 2, 4, 2 customer, right? Okay. So again, we can do the splitting. And this time, I simply use the random split. Okay. I just want to show you that when you have data of tens of thousands, hundreds of thousands of data points, okay, you don't really need to use this data split. You simply use the random sampling to have basically the same effect, right? As you can see that after I split it into split 2 now, okay, now I have now the split 2 vector actually split this 1, 3, 2, 4, 2 customer into a training okay, and also the testing in the ratio of 7 to 3, okay? And then again, I can check that. Although I'm using a different type of variable to do the splitting, the distribution of this amount variable inside the training and testing data set the distribution are basically the same. Similar, they are not exactly the same, but they are very, very similar to each other. Okay, so before we going now, we saved all of this data, right? Up to this point, we have already do the data splitting process. We complete the data splitting process already, okay, up to this point of time. So we set this data for later use, right? Okay, and then we already have the data to build our model, right? The result is something like this, okay? Let me show it here. I think it will be easier. Now, this is basically the data splitting process, okay? Okay. So up to this point, as you can see that X, Z, and A are basically this is the item, right? And sorry, this is the item, this is the transaction. And then we aggregate them into A, right? This is remember that Z and X only contain data in the first 3 months, right? So now we have this many customers buy from us in the first 3 months, okay? So for all of these customers, we can test whether they buy in the last month, right? And with that, we actually can build a model. This data, we split it into training and testing. Then we can use the SPO to split A into training and testing, right? These two 20,000 training data we use to train the buying probability model. Okay? Okay. But for buying amount, as I told you, that only those data who buy in February, okay? Only those customers who buy in February, their data can be used to train the buying amount, right? Because only the data who buy has the number of buying amount, right? And to build that buying amount model, you really need that amount variable, right? Okay, so out of this 2A, 5A, 4, only 13242 customer buy in February, okay? So we need to split it again out of this A2, and this is the data that we want to train. This 926A is the data that we are going to use to train our buying amount model, okay? And this 3973 is the data that we are going to train test the buying amount model. Got it? Okay. So it's kind of like pretty lengthy, right? As I told you, previously we give you the data frame. The data frame is already have the X and Y ready there. But actually, when you go to a real business real business context, a real business circumstances, you usually need to do a lot of data aggregation and data splitting before you can make the model. Get it? So any question up to this point of time? So I put this one of time. We have, as you can see that, we have a data frame, right? This is the most important data frame. And we have an A2 data frame, okay? Okay. As you can see that I do not set A2, right? Because I, simply by looking into A and looking into the by variable would tell us which of the A value is in the A2, right? Okay. So when you set the data, you don't want to set it redundantly, okay? You only set A, and then you can use the by variable within A to extract A2, right? And you don't need to set the training and testing separately. I only set the splitting factor, right? So later on, there's an advantage in doing this is that you actually can have a smaller data file, okay? And you don't set redundant information within the data file. The data file will be smaller and easier to manipulate, okay? So you only store the necessary information to make the TR, TS, TR2, TS2, okay? So TR, TS, TR2, TS2 can be made out of this variable that we set within TF3 that are data. Okay? Any question up to this point? So we split the data already and we are ready to build model. Okay? And after we build model, we can use this test data to measure the accuracy of the model. Okay? Good. Now let's, if no question, let's go to like the next notebook, which is building model and doing prediction. Okay? So now we are doing model, right? So doing model is quite straightforward. We're using the training data to train the model, and then we use the test model to kind of like test the accuracy, to measure the accuracy of the model, right? Okay, so actually before everything we kind of like clear the memory area and then load the data, right? And as I say that if we want to splitting for the buying probability model, we use this SP or splitting vector, right? Okay, which already been set in TF3 that are data as we will see here. Okay. We load the data, and we will see that we have A, X, Z, right? And as we can see, as we can see here, right? In this TF3, we can use these split vectors to get our training data and testing data for our probability model here. So it's right. We are using this splitting vector to split A into TR and TS. Now we have TR and TS. This is the training data and testing data for our logistic model, right? For probability, we already learned that we can call this GRM to, and actually we need to specify the family binomial, right? Okay, so this is the way to build a model. Note that I use this notation after the tilde. I put a decimal point here, right? Which means that I want to use all of this data except by to do as predictor, right? So first of all, within training, the customer ID, we don't want to use it as predictor, right? Because it do not have any meaning, right? So I start from variable number 2 and go to the number 9, right? The amount actually is the target variable for our amount model, right? So we jump over, we do not use it in our probability model, right? So here I select 2 to 9 and also the 11, and then here in this model formula, I can simply say by and tilde dot, which means that all of the variable except the by, which means the variable 2 to 9 will be used as predictor. Okay, this is the meaning of that. It will be easier. You don't need to like write every variable. When you have too many variables, this is actually easier to do the model. And again, after you call this function, very quickly you will get the model, right? And the name of the model, you can name it whatever you like. I just name it like GRM1. Okay, this is the model and this is the model summary, right? As you can see that for each of this numeric variable, it actually has intercept, right? It actually had the slope, okay, right, the coefficient. And for each of this categorical variable, for each label, it actually has a value. You don't really need to care about this coefficient because when you want to do prediction, you simply use you simply co-predict, right, function, and the first argument is the model, of course. The second argument is the data, right? Now you want to test the data, and you want to for each of the customer within this TS data set, you want to know its probability of buying, right? So you need to type equal to response. Remember to do that if you want to predict probability. Otherwise, it by default the predict will return the logit instead of probability. Okay, so because we want the probability, so we actually usually this is the basic pattern that when you co-predict on the logistic models, okay? And actually I put the data in PRED, right? So, and then with this PRED together with this by the value of actual by variable, and see this is actual and this is predict, right? And predict, when the predict is larger than 0.5, we will predict it as positive, right? And so with this table, we can very easily do, after we do the prediction on the testing data set, we can see that this is the true false, and true negative, and this is the true positive, right? And these two things are, these two area we predicted right, right? And these two number are we predicting wrong, isn't it, right? Because this is actual and this is predict, right? Okay, so with that we can very easily calculate the accuracy. Okay, the accuracy of the model is like you can actually use this expression to, because the diagonal, right? This is the sum of diagonal. CM is the confusion metric, right? And the diagonal of the transaction value is the correct one, right? And then we can sum the entire CM as the denominator, right? So very easily you can see that the accuracy is like about 70%. Okay. The reason that I want to compare it with the mean of test by is because that if I do not make the model, right, I simply guess, right, and because of 73% of the customer within this testing data set are no buy, okay, so if I do not build a model, I only use the value of this buy variable to do the prediction, I will have an accuracy of about 53%. Okay, so I just want to show you that after building the model, we actually can improve the accuracy of prediction from 53% to 70%. Okay, so not bad, right? Okay, so we can 70% is I think is acceptable, right? And if you are interested in also interested in the AUC, right? I told you that it's 70% is the accuracy is kind of like the classical model accuracy metric, but nowadays we would prefer to use the model accuracy measurement of AUC, right? The area under curve, right? Still remember the definition of AUC? It is the ratio that the model can correctly distinguish the two classes. Okay? This AUC is actually a number within 0.5 and 0.1, right? And it indicates the ratio that our model can actually distinguish the two classes. Okay? So this, if you want to see the AUC, simply call this and give it two things. This is the predicted probability, right? The vector of predicted probability. And this is actually the vector of this column, right? TS by, so it's actually a 0, 1 or true, false type of binary variable. Okay, so with that you can see the AUC. Okay. Okay, so we are done for the modeling and testing for the at this point we are done for the modeling and accuracy measurement for this buying probability model. Okay, so this is the what we see classification model and probability model, right? Okay. Now we proceed to do the expected revenue model, and this is the regression model, right? Okay, so and first of all, as we have done previously, we need to like extract the A2 out of A, right? Because that not every customer in A actually do a purchase in February, and only those who purchase in February has the buying amount, which is a must-have, right? We must have this buying amount to build the buying amount model, right? Very obviously. So we subset A and only choose those who buy and put it into A2. And we also do a mutate, right? As I told you that for all of this variable that concern the money, right? Basically, when we are doing business analysis in linear model, we very often we will need to do the log transformation to fit the normal distribution. And this is actually a requirement for, I should not say requirement, I should say the basic assumption for linear regression, right? So usually when you want to build a business model, and in the business business environment, usually this type of variable, they are not normal distribution. So you need to do a log transformation to make them normal before you do the linear transformation, right? And when you do that, you need to remember to like revert the log transfer when you do the prediction. I'll do it later, okay, as I will show you later, okay. So now after we pull A2 out of A and then do the log transformation, we can do the splitting, right? Again, we are using the SPO2 this time. This time we are using SPO2 as the splitting vector, right? Okay, and then, so we have the, now for the regression model, I simply put a 2 out of the name of the data frame, okay? So after splitting, now we see, oh, sorry, A2 is not found, so this is not, skip it again. Now you have TR2 and TS2, right? And this TR2 is we'll use it for training, right? And for linear model, it's you're calling LM, right? So it's easier. This is the same as what we already explained, and I named this model called LM1, right? And do a summary. Basically, you don't need to worry too much about the coefficient, as I told you, right? Because you basically can like use predict to get the predicted value, right? So if you want to see the R square for training data, then you basically can directly extract this data from the summary, right? So this R2TR, what is its value? Let's see. It's 0.28, right? It's the R square. And then for testing data, we need to calculate it ourselves, right? As we have done it again and again before. So this is the R square for testing data. So you basically can reuse the code, right? The formula is always the same. And this is just to compare the training and test R square. The training R square is like 2A4 and test R square is like 2A9, right? So they are basically the same. It kind of indicates that our model do not have too much problem, okay? the R square of like 28%, 29% is actually not very high, but usually when you are predicting a numeric value in a marketing when you are doing the monetary prediction for marketing, 0, 0.3, 0.4 type of R square is quite usual. Okay, so it's not too bad, right? Just actually in practice, the accuracy don't give you too much. It's not actually used in decision making. It just gives you the idea about how accurate the model is, right? Okay, so when you build a model and do the prediction, someone will question you, what is the accuracy of the model, right? So this is the process that you use to calculate the accuracy metrics, right? So right now we are using TR to build the probability model, right? And we use TS to get its AUC, and its AUC is about 0.78, something like that, right? It's pretty good. It's actually a pretty good AUC, right? And then we use this TR to build the bind amount model, right? And the R square of this bind amount model, when we test it, it is about 29%. Okay. So up to this point of time, we have already done the modeling and model testing, but here comes the now we have done the testing and we want to do the prediction. Okay, we have the split the data into training and testing, right? So we use this data to train, and we use this data to test. Okay, we already built a model for probability and another model for bind amount, right? And but this is not what we want, right? What we really want to predict is we want to predict what would happen in March, right? Isn't it, right? We want to use this model to predict what would happen in March. And that is the actual purpose, right, for our prediction. And up to now, all of our prediction is in February. And February data, we already know it, right? And because we already know it, so we know the accuracy, isn't it, right? But our purpose is not to get this accuracy. Our purpose is to predict the future, right? Want to predict for each of these customers, we want to predict whether he will buy, the buying probability of buying amount in March, which is in the future, right? Okay, and because our model, we are using 3 months of data to predict the following month, right? So when we want to predict March, we need to do aggregation again, and this time we need to aggregate the data from December, January to February, because this model is used the behavior of the 3 months to predict the following month, right? So when we want to use this model to predict March, we need to aggregate the data from December to February, right? So before we can do the prediction, okay, we need to do aggregation again. Okay, you get the point? You get the point? Okay. So far we have done training testing, and that is for measuring the model accuracy. Right? Okay. But our purpose is not to measure the model accuracy. Our purpose is predict the future, right? So when you predict the future, you need to aggregate the data again, right? This time you want to use these 3 months of data as X, and use this X, put this into the X, into to predict the future Y, right? Okay, right. So that is what we really need to do, right? Okay, so let's see how we want to do that, how we can do that. So we go into prediction, right? As I can see that, as we can see here, now we have done this, right? We use the recent data and final data to build model and check the model accuracy. And then we will need to use the latest data, right, to build X, and then use this X to predict Y, right? That is the real thing that we want to do, right? Okay, so now it's already about 11 o'clock, so let's take a break here, and we'll be back at 10 after 11. But there's one thing that I want to emphasize again, that we need to do a evaluation questionnaire, right? So please go to our Facebook group, okay, and do this evaluation questionnaire for this semester, okay? It's important to do that, otherwise they will chase my ass. So please take some time to do that, and we'll be back at 10 after 11, okay? Take a few minutes to do that.